In this session, we are going to practice writing lambda expressions for different scenarios. This is going to be really interesting, so stay tuned. To the main method, we'll write this function and we will try to practice to turn it to a lambda expression. Okay, first let's write a function. Before going ahead with writing lambda expression for this print method, let's first see how we can invoke lambda expression we had written earlier. We have declared lambda expression here, but will this block of code gets called as soon as we declare it? Let's test it by running the code first. I'll just comment this part of code and let me just run this. Okay, yeah, this way you will understand. So if you see, there is nothing printed over here. So you just created a lambda expression, but that doesn't mean the function is called. Okay, the lambda is not invoked basically. So how you invoke a lambda? You can just take a look at this. What you did is you called a function with an argument, right? You given an input and you invoke the function. Similarly, we need to basically invoke this lambda by giving some argument. Okay, so I'll just rename this string op, and then the way you invoke a lambda is like this, string of dot perform, because you see perform is the abstract method in string op interface, which is a functional interface. So you invoke lambda, as this lambda is stored inside string op, you can invoke it this way, and you give a single input parameter to it. So let's say coding wala Shree. So we need to print it. So it's out. I'll just put the code here. See, so that's how you basically invoke lambda expressions. We are taking another example where we have void as a return type and print is the name of the method. It is having a single argument and it is having a single statement which basically prints the given string. Simple one, right? So let's just copy the same thing. Okay, we need to figure out what kind of lambda expression it would be. Okay, so let's first do the same practice. Okay, as we have seen, this is an access modifier, not required. Print is the name required, no. Void is not required because it will figure out that this statement doesn't return anything, and what we give is hyphen and greater than symbol to show that it is lambda expression. But we have seen that we need to store this lambda expression into some functional interface type, right? So let's create a functional interface with matching signature of print. So interface printer, for example. Yes, now we have this lambda and this interface with one method with matching signature. So we can store our lambda expression into object of printer. So printer equals, and we are missing semicolon as it is a statement. See, again we saw that you need not give data type to the argument because it matches with the left hand side functional interface, and its signature says that it has void return type and it has string as an input argument. So you can omit it, it still works. We saw that there is only single input argument, so you can even go ahead and remove the parenthesis. Now there is one interesting part. If your lambda expression body has only single statement or return statement, you can even get rid of opening and closing curly brace, and it need not have the semicolon. Okay, this semicolon is for the statement and not for the lambda basically. So my code is super simplified into the single line, right? This lambda expression does the same thing that this function does, okay? And you can call this with, let's say, printer.print same string coding wala Shree, and let's try to run it. So by now you know how to write functional interfaces, how to write lambda expressions, and what is relationship between functional interfaces and lambda expressions. Now the next part, we saw functional interfaces, but we haven't seen some of the cases yet. In lambda expressions case, we haven't seen how to pass multiple arguments and how to handle them. In functional interfaces case, we haven't seen what will happen if we introduce default and static methods into it. What will happen if we will introduce some more abstract methods to the same class. So let's try to do it one by one. So starting with default and static methods, we know that our interfaces can have default and static methods. Let's say I have a default method, okay, void for example, and some method, and it basically prints I am a default method in string ops. Okay, let's see what happens to the lambda that we have written. Is there any compile time error? No, it is still good. Let's try to run the code and see if something happens at the runtime. No, so it didn't break anything. So introducing default method is safe. Let's introduce a static method and see what happens here. So static, I'll just copy the same thing. The purpose is to demonstrate you that it works. Some method we will call some static method. I'm a static method in string op, okay? And let's see what happens to the lambda that we have introduced. There is no compile time error. Let's try to run and see if there is any runtime error. No, output is the exactly same. So there is no impact of default methods and static methods, okay? Now the third case is, let's introduce a new abstract method in the same interface. So let me say void other abstract method, and let's see, does this break my code? It does break my code. So it complained about is empty and to upper. What do you think what has happened? So basically how Java compiler works is it tries to balance left hand side and right hand side, right? So left hand side is string ops, which supposed to be functional interface, because with single abstract method, because we have a lambda expression on the right hand side of equal to operator, but it checks the string op and it finds the two abstract methods in it. So it does not know basically that we are talking about a functional interface. It doesn't have a single abstract method. It doesn't have a single action to perform. So this code starts breaking, and as soon as we comment this abstract method out, it will again start working, because it knows exactly that there is only single abstract method. Okay, so this is one limitation set on a functional interfaces and lambda expressions, that lambda expressions should only assign to functional interfaces references. Okay, so developers, as we have seen, that being a developer, I'm tempted to write multiple abstract methods and interfaces, and this will break my code if it is a library that you are working on and somebody else uses your code assuming that your string op is a functional interface. It will break, right? So to avoid this, there is a compile time check given on these functional interfaces. It is nothing but a functional interface annotation. So you can mark this interface as a functional interface, and you can provide guidelines to the compiler saying that this is a functional interface, so don't allow more than one abstract method. So as soon as some developer tries to add another abstract method here, you'll start getting compile time error. So multiple non-overriding abstract methods found in interface string op. So this particular error start appearing as soon as we add abstract method to it. So we have seen that adding functional interface annotation is a safe way of working with functional interfaces. So it is always recommended to add this annotation, so you have a compile time check and your code is safe for functional interfaces and Lambda expressions. So that is a key takeaway from this. Okay, now the third thing that we haven't seen so far, so I hope you are good till now. If you haven't, just go back and replay the video till this point and then proceed with the next part. The third point we haven't seen so far is what if we have multiple arguments to our Lambda expression, what will happen, or how to do it. Let's introduce another functional interface. Okay, so with the good practices we have seen, let's create the printer as a functional interface, right? So this is again compile time. It will also introduce compile time check for a single abstract method. Let me write another functional interface, call it as a operation, let's say binary operation, because I want to work on two operands or two variables. Let's take example of add n1 and n2. So this is supposed to basically perform operation. It is a binary operation, so instead of saying add, I can say operate, right? Or perform is also fine. Perform on n1 and n2. This looks better. Okay, so my functional interface has only abstract method which is perform, returns integer except two integer numbers. Okay, so far we have understood that how to write Lambda expressions, right? So similarly we can write Lambda expression for this matching signature, right? So this is our matching signature. Fine. And in case we wanted to write this function in the class itself, how we would have written it? Let's do that first. Okay, so I'll just put it here and I will give some operation. Let's say n1 plus n2 is my operation to perform. So let's do the same thing, same practice. Let's copy this code. Now we know what is use of functional interface. So we are writing a Lambda expression for this matching signature, and this matching signature is in binary operation functional interface, right? So I'll say binary operation bop or binary operation is equal to, now we need to write Lambda expression for this function. So we don't need access modifier because compiler knows about binary operation. Looking at this, it knows what is the return type and what are the type of arguments it has. So it is safe to delete or omit return type, and type of arguments. Again, it is safe to remove name of the function because it is not required. It will be referred by the reference of binary operation and not with the name of the function. It is not required. And as we know, we need to give hyphen greater than symbol to show that it is a Lambda expression. Yes. And to further optimize it, we just talked about if it has only single statement, you can even get rid of the parenthesis, right? I'll get rid of the parenthesis and semicolon for the statement, because that is also not required. And it is a crisp code that is available. And let's see what it complains about. It complains about return, because it is really not required. See, so this is also not required actually. Okay, so return is also not required because there is only a single statement, and whatever operation you are doing, it will simply return the output, and whatever operation on n1 plus n2 is matching with return type of this abstract method, which is integer. So you need not give return statement. That syntactical sugar is not required. So yeah, looks good. So if you see, this is just a single line of code you need to write instead of giving whole this thing, you know. And let's try to execute it. So it has perform as a operation, and let's try to add 10 and 20. Okay, we need to basically print this out to see the output. Okay, fine. So the last statement should give 30 as a output, which is expected. Let's try to run this. Yes, the last statement gives 30 as the output. Thank you so much for watching this video. I'll suggest you to practice whatever we learned today so that concepts are clear to you, and that's how we learn coding, right? If you want to learn about some more Java features like default methods and static methods, I have recently added that video to YouTube. So I'm giving links in the description. Please do check it out. So finally, keep learning and keep growing. Bye bye until we meet again. Thank you.